Hello, and thank you for stopping by. This is a little and short video. It's a follow-up of the restoration video I made on this little Geloso radio, the 319 Geloso radio. I made a quite extensive video on the restoration of this radio, and it's in my channel. And the follow-up video, it's because I realized shortly after I started using the radio that the audio output tube, the UCL82, was running really hot. And I thought of maybe it was the voltages were wrong, and the biasing was also maybe incorrect. So then I took a look at the schematic, and here it is, if you remember, that this is the audio output stage, and you can see this UCL82. It has a small triode as a preamplifier and a pentode as a power amplifier, and you can see the rectifier there, here, that one, that rectifier which comes from the power transformer. This is the power cord, the power transformer. You can check all of this on the restoration video. There's a little filter choke, and this rectifier, single wave rectifier, and that generates the DC voltage. And that rectifier used to be a selenium rectifier. It was open, so I replaced it with a normal silicon diode. So I started thinking and realized that maybe the drop down voltage of the selenium rectifier was considerably higher than the practically non-existent drop down voltage of the silicon diode. So I realized maybe that the voltages on the plate and on all of the circuits was too high. And in fact, I measured the voltages a little bit and realized that the voltages on the plates, especially on the output tube, was really high. It was operating on the maximum permissible voltage. I've checked that in the tube manual, and it was working on its limit, and also the bias current was also working on the limit of the tube. So I decided to take a look into that, because I don't want the tube to have a really short life due to an incorrect biasing and voltages. So let me turn the radio around there, and this is the audio output tube, and this was running really hot. Let me show you on the underside of the radio the little modification I did, which basically is a drop down resistor before the power transformer, so that voltages are a bit lower, and now the tube is working in much cooler and well within the operating ranges specified in the tube manual. What I did here is to add a resistor here, there, a drop down resistor, so that the voltages coming after the rectifier are lower and more adequate for the whole radio to operate. It's a power resistor. It's composed of two power resistors in parallel, so to share the dissipated power and to handle things much nicer. And that's the modification I made. It's a 232 ohm resistor. Then as it can be seen on the underside of the radio. Well, this is the underside of the radio. maybe you can recall it from the restoration video, that I had to replace nearly all components inside, all resistors and capacitors. They are all new. Only a couple of them remain original. So I added this drop-down resistor. Here it's in series with the rectifier diode. This is because instead of a normal silicon diode, there used to be a selenium rectifier which had a much larger drop-down voltage. So the DC voltage coming out was significantly lower. Sorry for the shaky video, but I'm doing this quickly handheld in the camera. So where the fuse is, that I added this fuse during the restoration for safety. The selenium rectifier was located here and used part of the chassis as dissipation. This is due to the drop-down, the big drop-down voltage, that it requires some heat dissipation. Okay, so I realized, not at the moment, but as I mentioned before, after running the radio for a couple of days, I realized that the audio output tube was running really hot. So I started investigating and checking the current and the voltage, the plate voltage on the tube. It was running just on the maximum rating of the tube. If you check the tube manual for that tube, the UCL82, you can see that it was running just on the plate voltage limit and on the current, on the maximum current. So I decided to put this drop-down resistor here. It's a power resistor. They are two in parallel to share the power dissipation, and instead of putting one, I put two in parallel, so that power dissipation is shared between the two resistors. It's located in a place where the heat dissipation won't affect. There's nothing underneath, so no problem. It's far away from the electrolytics. I think there's no problem. And that put the operation voltage and current of the output tube, and I think of the rest of the tubes, because I verified the other two tubes, one of the other two tubes, and it was working well within the parameters. And now the tube is working much cooler, and I think it's working much better. I also added a little filter for RF, because it comes in through the power cord, and I took the chance to add this little filter that it has some effects in some places. I've been testing it outside of the radio for different conditions, and in some places makes little difference, but in other situations it makes some difference. So I decided to include it there. There was an empty space there, so I decided to put it there. Okay, these were the modifications done to the radio.